Welcome to Matematika. Today we're going to do some word problems in relation to linear equation. Let's do this. When digging into the earth, the temperature rises according to the following linear equation, where T equals 15 plus 0.01 H, where T is the increase in temperature in degrees and H is the depth in meters. Calculate 1. What temperature will be at 100 meters depth? 2. Based on this equation, at what depth would there be at a temperature of 100 degrees centigrade? So we'll start. Let's write solution here. For number 1, the equation is given as T equals 15 plus 0.01 H. But in question number 1, the depthness is given as 100 meters. So we can solve the T by substituting the 100 in the value for H. So T equals 15, 0.01 times 100, that's 1. So the temperature would be 16 degree centigrade. Okay. Let's do question number 2. At what temperature? So what is asked is the temperature. Based on this equation, sorry for that. Number 2, based on this equation, at what depthness would there be at a temperature of 100 degrees centigrade? This time, the value of T is given. Okay, 0.1 H. So we'll substitute the 100 degrees centigrade equals 15 plus 0.01 H. We'll subtract 15 on both sides. That would be 100 minus 15, that's 85, equals 0.01 H. To isolate our height, we divide it with 0.01. So H would become 85 divided by 0.01. That would be 8,500. That is meters. That's it. Simple. Using the linear equation. Let's have another problem. The population level in the center of a city at 6 a.m. is 30 ppm, that is parts per million, and it grows in a linear fashion by 25 ppm, parts per million, every hour. If Y is the population and T is the time elapsed after 6 a.m., determine 1. The equation that relates Y with T. 2. The population level at 4 o'clock in the afternoon. All right. Let's do the first question. So a solution here. So 1, Y in relation with T. Just like the slope-intercept form, that Y equals mx plus b. So we could relate with Y, and at the starting, it has a 30 ppm, but each hour it increased by 25 ppm. So that means we could have 30 as the basis, and then it grows up by 25 each hour. 25 times t. That would be the equation. From the equation, we can solve the population level at 4 o'clock. Now remember, it started at 6 a.m. and then until 4 p.m. So how many hours would it take from 6 to 4? So that means there are 10 hours. So from that, we can substitute the value of 25, 30 plus 25 times t, where the t is 10. So y is 30 plus 250, y is 280 ppm. And that would be the parts per million after 10 hours. So that's it. All right? Simple as that using our linear equation. All right, see you in my next video.